YouTube, this is my second in my video modules on logarithms. So we're going to talk about just a few special properties of logarithms, use them really quickly and be done. But I say up here, the following is a set of as a list of some very special standard properties of logarithms. Okay, and they're worth memorizing. This is actually very true. But we say these four up here. Let's go ahead and visit them. We say log base a of 1 is always equal to 0. Okay, so let's talk about this one really quickly. Of course, if we said log base a of 1, we get 0. But the reason why is if you rewrite this as an exponential notation type of expression, we say, well, what's our base? Our base is a. That's our base here. A to the what power turns into 1. So we say a turns into 1 if I take it to what power. And in this instance, we say it's this power right here. But the only thing you can take something to the power of and get 1 is 0. So just keep this in mind. Whenever you take log of 1, you always get 0 for an answer. Likewise, if we said log base a of a to the first equals 1, well, we say this, log base a of a is 1. Another way to rewrite this is like saying, hey, a to the what power? A is our base, turns into a how, okay? So a to the this power turns into this thing right here. So we say a to the first. You know, if you took a base, log base a of itself, okay, you would get 1 because if you took something to the power of 1, you get itself, essentially, okay? Number 3, this is very important, but we say these are the inverse properties here. What I want everybody to notice is this as you read through these. We say log base a of a to the x equals x, but really what we're saying is this log base a, notice that it has the same base as the thing it's taking the log of. Okay, so we say log base a is a logarithmic thing, a to the x is an exponential thing, and so this logarithmic thing and the exponential thing, they necessarily undo each other. Okay, that is if they have the same basis. Likewise, if we had a to the power of something, which is an exponential thing, but the exponent happens to be a logarithm, okay? And not just any logarithm, a logarithm with the same base, log base a of x, then we get just x, okay? So this would be like saying, you know, if I took log base 2 of 2 to the x, really, you know, it's kind of like saying, well, hey, you know, what could I take 2 to the power of to get 2 to the x? It's kind of a dumb question if you think about it. What could I take 2 to the power of to get 2 to the x? I would take it to the x power to get 2 to the x, okay? But this logarithmic thing and this exponential thing cancel out. And likewise, if I would have said 2 to the power of log base 2 of x, it's kind of like saying, well, I have an exponential thing to the power of a logarithmic thing, and they have the same basis, so they cancel each other out, and I'm left with just x, okay? And then last but not least, we say the one-to-one property. This is very important. One-to-one property of equality is my next video. We're going to focus on this, but we say if log base a of x equals log base a of y, well, then x and y is just necessarily intuitively obvious that you would get x as being the same thing as y. Okay, sorry about all these edit marks. I pull these out of a Word document. So, anyways, I say use the properties of logs to evaluate the following logarithmic expressions. And I see a typo on this first one here. Actually, I want to rewrite this. It should say log base 5 of 1. Okay. But using the properties of logarithms, I noticed right off the bat this. First of all, we could rewrite this as equals, you know, we could say y. But the fact is, rewriting this, we say 5 to the what power turns into 1, 5 to the y power turns into 1, but we get y equals 0. And the reason why is because the log of 1 all the time is 0. Should always be 0. But because, you know, anything to the 0 power turns into 1. Following up with this, the log base radical 7 of radical 7. Okay, really I'm asking this question is what I'm asking is what could I take radical 7 to the power of to get radical 7, okay? But notice this is our second property up here. We say log base a of itself should get 1. I mean, we should just get 1 on this one. But rewriting this, we say our base is radical 7. Radical 7 to the what power turns into radical 7? Well, anything to the power of 1 turns into itself. So we say the answer here is 1. And then last but not least, you'll notice that we have this exponential thing, 8 to the power of something. But we have it 8 to the power of log base 8 of 30, okay? So we're saying taking an exponential thing to the power of a logarithmic thing, exponential and logarithmic things undo each other, but if they have the same bases, we say, well, then this 8 and this log base 8 cancel out. We should just end up with 30, and that is just the second form of our inverse property up here. But learn these properties, memorize them.